Welcome back. This is episode 4 of Chemistry for Kids. Today we're going to talk about atomic structure and the history behind how we find the atom and such.
It is a fascinating journey, this path of knowledge, and the vehicle we ride is a science called chemistry.
Here we go.
So if we start off now, basically someone by the name of Aristotle,
You might know him.
he came up with the idea that there were 4 elements: earth, wind, fire, and water. Elements in quotations because they're not. So he came up with that idea. That was generally well received during that time. But as time passed on, there's this guy named Democritus who said, well, there's this one itty bitty small particle that is indivisible. And actually, he called it atomos, meaning that atomos actually means cut, and the A in atomos means not. So not cuttable, indivisible, do the math. So about 100,000 years later, or somewhere around that time, we have a person named Dalton, who basically copied off of Democritus' homework and said, yeah, I agree with that idea. I think there's an indivisible particle out there. And Thomson later on said, okay, so I'm going to add on to that idea. I'm going to say that there is an invisible particle, but there's electrons. And he made a diagram called plum pudding that basically said that, okay, so there's negatively charged particles and there's positively charged particles.
Well, they all make this plum that is positive. So this entire thing is positive, while there's individual negative particles within the model. And how he found that, you know how he found that, right?
How do you find it?
Well, he used a cathode ray. He was able to actually detect negatively charged particles, and that's where he derived this conclusion from.
Okay. That's nice.
Yeah.
All right, Rutherford now.
Yeah, he had the gold foil experiment. Funny enough, with Rutherford, he discovered the proton, positively charged. He was also able to discover the fact that there's a nucleus within the atom, so he was able to construct his model based on that, with the positively charged proton in the middle, as a nucleus, with the electrons being on the outside. I found that with the gold foil experiment is basically he shot alpha particles at this golden foil, and the expected result is that they should pass through, but in fact, they bounced off. So, in trying to reconcile this weird observation, he was able to derive that there was a positively charged particles from that would cause that reaction. So next we have Bohr, which, like his model is sort of, like I feel like a lot of people would think of that model. He focused on hydrogen only, but that's an experimental error, you could call it, because it's not encompassing all the other elements and trying to see different perspectives. So and of course, how he interpreted that is that the negatively charged particles, or electrons, in this instance, would be orbiting the nucleus, and in this way, he was able to derive these orbitals that surrounded and orbited the nucleus.
It works pretty well for hydrogen.
Yes,
So,
yeah. But not
anything else. It's like
not exactly.
it's kind of it's bogus. Sure.
But modern day, we trying to compromise that idea with a new simple version, and trying to bring in quantum mechanics into the mix. I'm talking about very small particles, and how a big thing in quantum physics and mechanics would be having to do with the probability of said electrons being within this space. So this was able to support this model itself, in which it's supposed to be an electron cloud around the nucleus, and what that suggests is that there is the electrons themselves are within this space, but in terms of where exactly they would be in that space, it's just determined on pure probability, and they could be anywhere in that space at any time. So, as a way to sum it up, or the key components that you would want to think of when you're thinking about neutrons, protons, and electrons is that neutrons, funny enough, in discovering that was discovered by Chadwick, who through deduction was able to notice that there was an excess mass of several different compounds and particles, and was seeing how there is this weird excess, right? But the only particle that we know of, or knew of at the time, that would compose that mass was the proton. So he derived this idea that there was this neutrally charged particle that must have existed with the proton at the nucleus that was able to compensate for this error in mass that was observed. So that was discovered by him, neutrally charged by Chadwick. That's important. With 1 atomic unit, that's how much mass it has. Protons, that's positively charged. That was discovered by Rutherford, as we already discussed, and is its mass is 1 atomic unit. And in terms of electrons, it's
no atomic mass.
Yeah, it's so small that it's basically negligible. But as we know, discovered by Thomson, and has a negatively charged. It's negatively charged.
Okay, so moving on to isotopes. So as Professor Boron explained from before, that Chadwick discovered the neutron, meaning that there's some sort of excess mass, but the elements that can come up with this excess mass can come up with various numbers of neutrons, and that's what isotopes are. So we have something like carbon here that has 6 protons. So usually you denote it by C12. So if a carbon has 6 protons, that means it has 6 neutrons as well, adding up to 12. And so that's the various numbers of isotopes that you can see there. When you have something like this, where you see a positive and a negative charge, positive means you're taking away that electron. Since electrons are negatively charged, you're taking away a negative, it means you're becoming more positive. But if you're adding an electron to some sort of element, then that's going to be equally more negative. So,
and then don't forget that these are called ions.
Yeah, they're called
ions would be a key factor in terms of in identifying in the cases that there would be changes of electrons, as well as the isotopes being characterized by the different neutron.
And when you want to denote carbon, something like this, if you want to find out the neutrons, let's say a carbon-12, and you find the protons, and you find the electrons. So we know that the protons are 6, right? But since it's 12, so we add the numbers. Once again, it's 6. But then this is the protons will equal the electrons, which means that this is also 6 as well. So if you have so if you have C13 again, so same thing, proton.
You should probably move so the audience can see.
Okay. My apologies. And then you have the neutrons, which is 7, and then once again the electrons will stay 6.
You might want to. I don't know. I still think that they can't see. What are you doing, Mr. Chemist?
What?
Come on.
I'm sorry. It's a lab coat. It's
I think
kind of in the way.
Yeah, you're getting too involved now.
Okay, so when you have something like that, that's how you denote it mostly. So you have ions, you have the isotopes, and you have the different sorts of things that make up the atom. These 3 things are components. We can get it even deeper. We can say the electrons, protons, neutrons have.
You talk about quarks, but hey, that's a bit advanced. We're not going to talk about that.
That's more of a
that would be more involved with quantum physics, yes.
And that is it.
Well, that's how we're going to wrap it up. So,
yeah.
Stick around.
Stick around for more for viewer submitted questions.
Yes.
And meet us in the next episode. What's the next episode?
Next episode, I believe, has to do with electron configuration and notation.
Electron. You doing that one?
I believe I am doing it.
Okay. And with that, Master Chemist, signing off.
Farewell.
Peace. Welcome back to the Chemistry Corner. This is the 3rd installment of this mini-part series, and let's pull out more questions since we have those. It's getting more stacked. And the first question is from a concurrent viewer, cock_lord, and his question is address. Oh, address for the sodium. Okay, I'll get back to you on that. I'm gonna jump in the email. Second question is from Benjamin D21, And his question is, why should I take AP Chem over AP Bio? So I'm not going to sway any opinions here, but AP Chemistry is it's a little bit more important than AP Biology. And that's my take. So yeah, just take AP Chemistry. Finally, third question is from Snakes Are Real on TikTok. And his question is the moon a perfect sphere? Okay, well, considering it gets hit by multiple asteroids and it has multiple craters, I would assume it's not a perfect sphere. But I'm gonna say it is a perfect sphere on this one. So yeah, there's your expert take on that as well. And that's it. Those are all the questions. Make sure to submit more questions in the next video. We'll be sure to respond. And the best questions that get the most likes, we will answer. So yeah, this has been the Chemistry Corner. Master Chemist, peace out. Welcome back to the ionization interviews. And today we have, you want to introduce yourself?
I'm Christian Herman.
Yes, it's Christian Herman. And can I ask what science you're taking?
Biology.
Biology. I have a few questions for you. First question, why are you taking biology?
Because I need it for college.
And how does biology correlate with your college career?
In college, I will need to take biology because I want to be a doctor.
A doctor. And does being a doctor have anything to do with chemistry?
Yes.
It does. Then why don't you take biology? Simple.
Because it also
back in the cycle.
has to do with biology.
More biology than chemistry?
Yes.
Okay. Now, is that your favorite subject though? Biology?
It's
Science
a little
subject.
difficult.
It's a little difficult.
It's a little
Would you have felt the same way if you took chemistry?
I think it would also be a little difficult, but it might be like easy.
So the chemistry portion would be easy.
Maybe. I don't know.
Okay.
I didn't take it.
What's your GPA?
4.5.
Got a smart man here. Smart man. Taking biology. But those shoes though, they're not that smart.
The moral of the story is if you want to look smart, you gotta take chemistry and have the Gucci science.
AP Chemistry. AP Chemistry.
He's absolutely right.
Over summer, better study stoichiometry. AP Chemistry. AP Chemistry. Over summer, better study up to chapter 3. Call me MC Delta T cause I be sitting heat. Call me Lambda Nu cause I be wavy on the beat. Negative my entropy cause I be hella neat. Positive your Delta G cause you'll be hella weak. God damn, changing modes into the grams. Check mode ratio, check the suffix, then we do electrochem. Got my anodes, got my cathodes, and the salt bitch in my hands.